Long division of polynomials can be pretty tedious, especially if we have higher order polynomials than something as small as x squared. It takes a long time, there's a lot of places for us to make a mistake. So fortunately there is a faster, easier method that can be used under some circumstances, and that's called synthetic division. And so it's something that shortcuts the algorithm, basically does the steps in a much more condensed format, and so then we can use the answer and transfer it to a regular polynomial by just working with the coefficients of everything that we see. Now the first thing is the divisor, so the x minus 8 that we see here, has to be in the form of x minus r. So that means there can't be a coefficient in front of the x. And it doesn't have to necessarily be subtraction, but it needs to be x and then plus or minus whatever number it is. But the default is x minus r. So in the example that we see here, the value of r, since it's x minus r and x minus 8, the value of r would be 8. And so then for this synthetic division process, we actually use an upside down box like the one that we see in front of us. And then r, that divisor, is going to go on the outside of that box right here. And then inside of the box, kind of across the top here, is we're going to put the coefficients of the polynomial we're dividing into. We just have to go from the highest down to the lowest. So the coefficient in front of x squared is just 1. Then the next coefficient is negative 5. And then the next coefficient is this last integer piece, which is negative 24. So I don't need to keep the x squared with it or the x or anything like that. And so I'm just copying down the coefficients across the top there. Now we can start our division. And so our first step always is going to be to take this first number and then just bring it down here. Whatever that number is, that's going to be a part of our answer. It's going to kind of kickstart our process. And then we're just going to use this guide here. In the vertical direction we add. So we can almost think of it as if there was a 0 there. So we added 1 plus 0 to get 1. So in the vertical direction we add. Now in the diagonal direction I'm going to multiply. So I'm going to take 1, this number that I just brought down, and I'm going to multiply it times r. And so I'm going to multiply 1 times 8. I'm going to get 8. And so then I'm going to put that number right here. And now I'm just going to repeat that same process until I get all the way to the last column. So in the vertical direction, again, I'm going to add. So I'm going to add negative 5 plus 8. So that gives me 3. So I'm going to put that right here. And then I'm going to multiply on the diagonal here. And again, it's 3 times the divisor. So 3 times 8 gives me 24. One more time in the vertical direction, I'm going to add. So negative 24 plus 24 is 0. And so now that I'm done, this last number is our remainder. And then these other two numbers are the coefficients of our answer. And they're the coefficients in front of the variable x, one starting from one less exponent than our divisor had. So if our dividend had. So if our first term right here was x squared, then this is going to be the coefficient in front of x. So we're just going to have 1 times x, or just x, and then we just go down from there. So the next term is going to be just an integer piece, and so since that's positive 3, it's going to be plus 3. Or we could just write x plus 3. And since there is no remainder, we don't have anything else in our answer, and so this is our result. If we had done this via long division, we would have gotten the exact same answer, would have divided evenly, x plus 3 would have been the result with no remainder. So as we practice this, we're going to see that this is really a lot more efficient, a lot faster way of dividing polynomials. So let's take a look at a second example. So again, none of this is possible unless our divisor is in the format x minus r, which in this case it is, so it's x minus 2, so that means our divisor is going to be 2. We're going to use the opposite of the positive and negative sign that we see there, so we're going to put a 2 there. And so now inside the box, I'm just going to put the coefficients going down from the highest down to the lowest, and so I've got 9x cubed minus 18x squared minus 16x, and then plus 32. So I'm just writing the coefficients down. And so once I've got my setup, remember in the vertical direction, we're going to add, and And then on the diagonals, we're going to multiply. So, kickstart us, I just bring that first number down. Again, we can think of this as being a 0 here holding the place. So 9 plus 0 is just 9. Now I'm ready to multiply. So this direction here, I'm going to multiply. And so I'm going to multiply 9, the number I have down here, times the 2 times the divisor. I always go back and multiply by the divisor. So 9 times 2 is 18. So now in the vertical direction, we're going to add. So negative 18 plus 18 is 0. So now we're ready to multiply again. So 2 times 0 is, of course, 0. And then in the vertical direction, we're going to add again. Negative 16 plus 0 is negative 16. And then we've got one more round here. 2 times negative 16. I'm going to multiply to make negative 32. And then 32 plus negative 32, one more round of addition, we get 0. So now we need to translate this into the actual polynomial answer. And so remember, this 9 here was the coefficient, this 9 here was the coefficient in front of 9x cubed. So that means this 9 here is going to be the coefficient in one lower exponent, so it's going to be 9x squared. And then I have a 0 in front of the x term, so I could say plus 0x, or I could just leave that out. And then the last number is just going to be minus 16. And then once again, we don't have any remainder on this one, so we could clean this up a little bit and just write our answer as 9x squared minus 16. For our third example, we can see our divisor is set up properly. It's in this x minus r format. So that means r is going to be 4. And just to be clear, if this had been plus 4, then x minus r would mean that r was a negative number, so it's just the opposite of the positive negative sign we see. So then we would use a divisor of negative 4. But we don't. We have an x minus 4, so we'll go back to positive 4 as our divisor. Now for the inside, I just use the coefficients of my polynomial here. But you'll notice we've got 3x cubed, so I've got a 3 there. I've got negative 10x squared, so I've got negative 10 next, but I'm missing the x term. So just like we did with our long division, we have to make sure that we include a placeholder for the x term that's not there. So that coefficient is going to be 0, and then I'm going to have negative 22 at the back. It's super important that we remember and pay attention for that, because unlike in the long division, where we'd kind of get a signal that our like terms aren't lining up properly to kind of catch that mistake, with the synthetic division, we would never catch it if we don't notice it at the very beginning. So an important element of this. So once we've got our setup, we can start with our vertical direction we add. So we start off by just bringing that first number down, kind of imagining that there's a 0 there to kick us off. And so now we're ready to multiply on the diagonal. So 4 times 3 is 12. I'm going to add in the vertical direction. Negative 10 plus 12 is 2. Multiply on the diagonal again. 4 times 2 is 8. Add in the vertical direction gives me 8. And then 4 times 8 for that last diagonal gives me 32. And now I add one last time. Negative 22 plus 32 gives me a remainder of 10. So this time I have a remainder in my answer. So we go back here. Remember, the original 3 that was right here was the coefficient in front of x cubed. So that means this 3 right here is going to be the coefficient in our answer polynomial in front of x squared. So I'm going to have 3x squared, and then plus 2x, and then plus 8 for the 8 right here. And then that remainder of 10, I'm going to put that over the divisor. So I'm going to go plus 10 over, and then my divisor is the full x minus 4, so I put that over x minus 4. So there's our result. So we get the same thing as we do via long division, just in a much more efficient manner, and we can use this as long as our divisor is in this x minus r format. As long as there's no coefficient in front of the x, we're good to go.